All right, so there's some more vocabulary that I like to go over in our exponents unit, and defining exponent is a good place to start. Then we're going to talk about bases and coefficients. All right, so an exponent. What is an exponent? An exponent is a number that is telling us how many times another number should be multiplied against itself. All right, let me explain on the board right here. Let's say that I have 5 to the third. All right, 3 right here is the exponent. I'm just going to say exp, short for exponent. So 3 right here is the exponent. And again, let me go back to my definition. An exponent is a number that is telling us how many times another number, in this case 5, should be multiplied against itself. In this case, this 3 is telling us that we want this 5 to be multiplied against itself, against 5, this many times, in this case 3 times. So what this means is 5 times 5 times 5. That is a representation of 5 to the third. There are a couple ways that we can say this. We can say this is 5 cubed. We could say it's 5 to the third power. We could say that it is 5 raised to the third power. Those are all ways to express this same idea, what we're having right now, which is having 5 multiplied against itself 3 times. So if I had a 4 here, if it was 5 to the 4th power, or 5 raised to the 4th power, then I would be wanting to multiply 5 times itself 4 times. So it would be 5 times 5 times 5 times 5. And so this is the expanded form of what's going on right here. Let me write that down. Expanded. That's a vocabulary term. Expanded. So if I wanted you to write something like this, which is in exponential notation. Remember our last video? This is in exponential notation, but if I want you to rewrite this exponential notation in its longer form, then I would ask you to expand it. All right, so let me give you one more example. If I had 2 to the 4th power, all right? If I had 2 to the 4th power, 4 right here is the exponent. It's telling me that I want to multiply 2 times itself 4 times. So in our expanded version, it would look like 2 times 2 times 2 times 2. Now, again, using our vocabulary term from last time, if I wanted to not only just expand it, but then evaluate it, what would that be? I'll let you think about it for a second. Okay, so if we were to evaluate what 2 times 2 times 2 times 2 is, I want an actual number of what this is representing. I want to figure out what this is equal to. So this is, in this case, representing the whole quantity, 2 times 2, which is 4. 4 times 2 is 8, and 8 times 2 is 16. So therefore, 2 to the 4th power evaluates to 16. All right, so that's using a little bit of these vocabulary words. A power is the same thing as an exponent. All right, so I could say this is 2 with a 4 as an exponent, or I could say 2 to the 4th power. Both mean the exact same thing. All right. Now, there's a word that we can call 2 in this case, or the number that we have this exponent acting upon, all right? So this exponent is telling us to multiply this 2 against itself this many times, 4 times. So 2 in this case is under, you could say, the power of 4. So a number that is under the power of an exponent is called a base. Right here. So this is the other vocabulary word. So the number which the exponent is acting upon, that is the base. So here 2 is the base and 4 is the exponent. Again, 2 times 2 times 2 times 2 is the evaluated form, and 16 is the 2 times 2 times 2 times 2 is the expanded form, and 16 is the evaluated form. There's one more vocabulary word that I'd like to go over, and that's coefficient, all right? So as I said, a base is acted upon by the exponent. But what if there's a number involved in an expression that's not acted upon by the exponent? Let me give you an example. What if I had 4a to the third power? Okay, so this 3 is an exponent, it's a power, and it has power over the a. It does not have power over the 4, okay? And I'll get into how we would express how we would want the 4 to be under the 3 exponent power. But right now, 3 is not having any influence over this 4. It doesn't have any power over the 4. It only has power, this exponent, or all exponents, only have power over what they're directly touching. In this case, the 3 is only having power over this a right here. So therefore, if we were to expand this out, this would be 4 times, and then a is being multiplied against itself 3 times. So that would be a times a times a. This is an equivalent expression to this first expression, okay? So since 4 is not being acted upon by this 3, by this exponent, we call it a coefficient. It is a number that is placed in front of a term that is being acted upon by an exponent. Yet, it is not itself under the jurisdiction or the power of that exponent. So that's what a coefficient is. All right, now you're saying, maybe, how do I get that 4 to be acted upon by the 3? How do I turn, so to speak, this coefficient into part of the base? Well, this is how we do it. We put a parentheses around the entire part that we want the base to be recognized as. Now, the 3 is acting upon this entire parentheses because it's now touching this parentheses. So if I were to expand this out, it would be a very different thing than what I had before the parentheses. Let's expand this out. This is saying the base, which is now not just a, now it's 4a, because everything in the parentheses is going to be considered a base. It's going to be 4a as the base times itself 3 times. So to expand this out, this would be 4a times 4a times 4a. This is what the expanded version of this particular expression is right now. So if I wanted to evaluate it, I would actually be multiplying 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64. So it would be 64, and then since a is a variable and I don't know what the value of a is in this particular case, I'll just have to multiply a times a, which is a to the third, or a cubed. So therefore, in this case, 4a as a quantity, all raised to the third power, evaluates to 64a cubed. And there you go.